VP said when we showed them, we can miniaturize all of our stuff into the nut. No, I need to be able to rent this for 500 quid a day. I can't do that. They told us that, like, outright.
All right, welcome back. Thanks, everybody.
It needs to look expensive in the rental shop.
I think as someone already noted, Kieran is on this panel, but he's not the only one. We've also got David Atkins, Phil. I mean, these guys, this is likely to be an interesting panel. Thank you, everybody, for participating.
Only likely.
Only likely to be. I'm trying British understatement. I'm not at all good at it.
Don't oversell us, will you?
Yeah, but anyway. Andy, if you would, I believe we're going to have a discussion about live compute, so take it away, please.
Thank you very much. Well done to everyone that's made it back up. The last run, you've got us and Sydney, between now and the end of the day. So welcome to this esteemed panel. I'm going to do that in a minute. They're going to lean forward to their microphones when they talk, and also they're going to tell you, amongst other things, their favourite ice cream. So get thinking about that. Just a reminder, I've used this picture yesterday. I just wanted to remind us what we're talking about here. We're talking about the fact that we're moving to a software processing chain for live production, which is or should be used inherently asynchronously, and we're going to unpack that as we start. We're also going to talk about how that impacts the work we've done within VSF that we've been doing for the last, I was going to say couple of years, but apparently people tell me it's longer than that. And also, just a quick plug, by the way, there is an IBC accelerator activity, of which there is the initial meeting tomorrow, but you don't have to make that one. We're looking for more people to be involved in that, and it's all about prototyping a DMF-friendly linear compute interchange of data. So we'll, if you want more details on that, I meant to plug that yesterday, so forgot that. Okay, so here we go. We can jump through that. Here is the esteemed panel. I'm going to get them to introduce themselves. We're going to start this end. Felix, you're going to have to use the handheld radio mic. So who you are, I know most people know this about most of you, where you're from, why you think you're up here for this panel, and what's your favorite ice cream? Okay, Felix.
Okay, Felix Poulain, CBC Radio Canada. Why I'm here? I think we are at there's a big momentum growing on the topic we're going to talk about. I think it's very important that everybody kind of start to reflect on this, if it's not already done. So I think it's an effort to pursue that discussion, and it's very important that we repeat that over the next few months to get to a common understanding of these concepts and that we make it happen. Favorite ice cream, maple sugar chunks.
Beautiful. What a sugar rush you get. Okay, right. Do you want to lean right into your microphone? This is yours. Just use it closely. Hang on, you have to press a button. That's right.
Right. It's audio, I don't understand audio. Sylvain Coup at Riedel, from Canada also. My favorite ice cream is sorbet, mango sorbet. Why I'm here? I think customer would demand cut space workflow, and we need to address that before it's too late.
Before it's too late. What an imperative. Kieran.
I am Kieran Cunha, founder and CEO of Open Broadcast Systems, not to be confused with the OBS streaming software. I wrote about maybe 1/3 of the GCCD document, it's probably fair to say, Andy, about 1/3 of it maybe. And I've presented a lot about software, technology, and I think, that's why I'm on this panel. So based in London, and my favorite ice cream is macadamia nut ice cream, especially from Hawaii.
Very good. Let's get some good comments from the audience. Phil.
Hi, my name is Phil Myers, CTO at Lavo, responsible for the engineering team's product management. Why am I here? I think I spent the last 3 to 5 years of my life talking about this, passionate about this topic. I believe it's absolutely the way forward. And so I think you probably got that in my last session. I think this is really important to the industry. What ice cream do I like? I like sorbet. Is that an ice cream though?
Yeah, that counts.
Yeah, okay. Yeah, lemon sorbet.
Lemon sorbet. David?
So, yeah, David Atkins, frame on the screen here. I'm here because Andy told me to be here, so I could talk about... So I could talk about that. And stem ginger is my favourite ice cream. We've been working on implementing the kind of technology that's in GCCG in one of our products, so I've learned quite a lot about it over the last 18 months, and we've been working with Appear on the demonstration downstairs where we have actual GCCG version 0.9, I think, probably running on a platform. So.
And that's a demo we demonstrated yesterday afternoon. Wonderful. Okay, let's start going back to that picture of a couple of times ago. In fact, I will go back to the picture just to get there. This asynchronous thing. I think it's really important that everyone understands the inherent break we need to make with linear synchronous connectivity. So who wants to kick off by giving us a little explainer as to why we need to go to asynchronous interfacing for compute? Gosh, you've got 5 people that are just brilliant on this topic, and none of them are going for it. Okay, Kieran, go on. You give it a first stab.
General purpose compute does not process, video in a linear lockstep fashion, be that SDI timed to, well, in the US, so 33 milliseconds per frame, etc., etc. Software processes video as and when, so potentially depending on what the software is doing immediately, or it might take some time, and that's important because you can now hand off processes to different vendors or different instances in a cloud, or what's the phrase, composable compute environment, and pass that off as quickly as possible in a compute-friendly manner. But the downside of that is this needs to be reconciled to what Andy has on his right. I think this diagram's great, actually. To the linear chain, be that a linear chain on the ground, be that SDI or 2110, or a physical device. And so timing is important because of the inherent bursty nature of compute to reconcile that to something on the ground. Yet that content, of course, is being captured in a linear fashion. So the thing in between needs to be time aware. And all the processes involved in production as well need to have some semblance of time awareness, but not everything needs to be time aware. Some things can be done as quickly as possible.
And part of this is that different processes take different amounts of time. Audio can be very quick to process compared to video, depending on what you're doing with it. Your CPUs will make a huge difference. The scheduler on your operating system will massively affect the amount of time your process gets. So you have this built-in elasticity from all these elements of it. And some of the processes will be done in 2 milliseconds, where you might have 20 milliseconds in a frame. So potentially, you might be able to concatenate 10 of those 2 millisecond processes and run 10 times faster in real time. But when you do that and you load the system up, then it'll extend because we're using that resource for other things. So we have to work out what the worst case is and have margin to handle that so that we can always deliver the combined result at the back end when we're going back to people who like the video and the audio to come out at the right time, synchronized for consumption.
Any more points on asynchronicity we'd like to make? Phil?
I think I would focus on the production thing at the block at the top here. So one of the things that we're going to inherently gain, or a demand that's going to come from the customer side, is if you converge all of your content onto the same network, IP fabric, or generic IT compute, you're going to be able to do workflows that are both live and non-live. And so that will bring a number of benefits of being able to take grains or frames out of the network and put it down to disk, and also get it back out to reconstitute content that can then be played out linearly at the other side of the chain. So I think this will unlock workflows that we inherently couldn't do in some of the other ways without complexity. So,
only I would say the latency buildup in the linear chain with 2110 compared to even SDI, we introduce so the base profile of 2110 is asking a strict timing requirements with TR offset 0, whatever, which means that a lot of process will wait for the top of frame back to the epoch before starting the next frame. And because of that, we've seen a buildup of latency compared to SDI, where some of the elements in the chain will synchronize to the house clock, and some of the elements in the chain will just synchronize to their input, which is not a mode that is widely used in our system. So here's we're going to the other end of the extreme of that is we're not going to wait anything if not needed, which is if the frame is available, we can start the next element in the hop can process it. And so in total, in the full chain, we can reduce the latency, which is very important for some of the workflows where there's re-entry and feedback.
Thank you. Whilst we're talking about time, and that's one of my favorite pet topics, as many of you know, one of the things that I think was being cited when we talked about production going on to compute was the necessity of precision time protocol and uber accurate time being available in every point of the compute to allow it to do this processing. Now, my argument is that's totally unnecessary, as long as we have origination timestamping and it propagates. Does anyone want to argue with me or take up that point and actually talk about the concepts there?
Well, I would agree with you. If you don't see the media or you don't hear the media, there's really no point into aligning the timestamp, right? If you process it, if you scale it, and to hand it off to something else, you just need to be aware and keep the time as a reference for a downstream process. But if you don't consume it and you don't see it, hear it, there's no point. Why would you need to care about that?
Couple of things. One here in terms of precision, I think that for many use case, the precision is the size of the grain where you need to realign images. A video frame is the precision you really need, or half of it to have the kind of 2 times the precision you will use. It's more tricky for audio. It really depends. If we want to tolerate timestamping that is a bit loose, using something like NTP or something that is not as accurate as PDP, probably we need to think about how we organize the audio that belongs together in the same audio object, like a 5.1 image needs to keep its coherence. So that there must be a way to achieve that. But I think this is all addressable. This is something we can find a way. But more fundamentally, I think we have this time to make it right, and we don't have a choice in this case because of the asynchronous nature of it. We don't have the choice to have a solid methodology for timestamping and understanding how it will work before we can even start working. Where we could tolerate in the past doing that manually with some delay at the right place, here we are going to build dynamic facility. The delay will be something that will change all over the time, all over the day. So we need to have the right model. But I think we know we know how to do it. It's just a question of doing it now.
Yes, we were having a conversation earlier on mistakes made in the past, and whilst I was a significant part of the 2110, especially the timing model, and thinking about the timing propagation. I think talking about the precision of time stamping and the audio and video acquisition, of course, those devices are the things that are not going to be in the software ecosystem. So it's quite possible, and I would argue, that we have a nice accurate timing that the A to D converters and the cameras actually have decent accurate time, so they can all be timed very accurately, and then the compute can just process those frames within that. Okay, that's very good. One other big thing that I think has been talked about, and I know it's something, Felix, that you've had a passion about, is the agnosticism of the hosting that this software is on. So the platform agnosticism. Would you like to open with that, and then we'll throw open to the team as to what the driver is there and what that abstraction needs to be to actually make that viable?
Yeah, I mean, the dream for user is to be able to select media functions that are addressing their needs. And in order to achieve that, we would like that to be able to choose any vendor, but at all layers. And the whole infrastructure, the whole move to IT is to leverage IT, not only what's available today, but what will be available in 5 years, because this is evolving quite quickly. So it's really important to have the right abstraction in the stack to be able to leverage today and future technology in terms of the whole IT and CUTS technology at the bottom, and to be able to select the vendor and the functionality we need to build our workflows. So yeah, that's the multi-vendor project that we could achieve in the past by having standards like SDI or 2110, and then there's a control bit, so above it, where we need also to have ideally one way, but at least a limited number of open ways to achieve control and orchestration. That will be the dream. Let's work toward this.
Let's stay on the platform agnosticism if we can for a while. Phil, are you ready to go?
So I think from a vendor side, I think I said this last year, if you look at the evolution of that investment, we as a broadcast industry in the current state of the industry, it's hard for us to keep evolving the technology that quickly. So if I look at the compute that we were putting in projects, even just over a year ago, 64 cores, now we can get 128 cores. The servers are cheaper. They've got 200 gigs NICs instead of 100 gigs. We already have 192 gig with 400 gig interfaces. As a hardware perspective, it's really hard to keep even respinning hardware platforms at that pace. It's just not sustainable. And so the other side of it is, if I look at the supply chain channels that we had as a vendor over the last couple of years due to COVID and a number of other things, being completely abstracted from the hardware gives me the ability to look at really across the supply chain. So whether we're putting Intel, AMD, ARM, whether it's Arista, Cisco Fabric, it gives a lot more flexibility. But it does give you some other challenges, which is you also have to look at your business and where the value you have is. So, especially in the software layer. So I think certainly from our side, the underlying infrastructure is going to move so quickly, probably quicker than anyone will expect, and it's only good for us from a software vendor perspective to take the benefit of that.
David?
For me, it's about trying to offer the customer something that will run anywhere without telling them it has to be on a specific platform. But within that, to make that happen, we still have to be able to test those systems and deliver them, measure their performance, and understand how they run on a platform. And that brings in things like orchestration layers. Are we going to run with OS on the host? Are we going to run in containers on Docker? Are we going to use Kubernetes? And these are all decisions that will affect it, because each of those has a different control plane that we'll have to use. And I think as an industry, we'll probably have to find ways of finding a common standard that will allow us to manage these things to make the customer's life easy. And also, we don't want all our customers to suddenly be Kubernetes experts or Docker experts, or indeed possibly Linux experts. So we have to find ways of delivering this that allows it to be easy to deploy without horrendous amounts of IT overheads and bringing in all those ML ops people that you didn't want to have to bring in to run a simple broadcast process. So there's lots of challenges with what IT brings us around the cost of implementation and the human cost that goes with that. So I think they're fantastic and what we can do with it, but suddenly you get a load more pain that you have to work out to manage. And I think to make that easy for people, we're going to have to find out how to make that happen.
Yeah, totally agree on that. But I think the challenges will be to sizing these process that we will be sharing, right? We'll be running in the same hosts and whatnot, but then every process has its requirement. Every kernel, every whatever process you have will have resource requirement, and that is the next challenge that I think we'll have is sizing these requirements and sharing that.
So I'd actually disagree with David. I think we need to get real and stop telling customers Santa is still real. You're going to have to learn IT. I mean, it's the reality of the situation. You're, hiding technology behind push buttons, etc. It just isn't going to happen. Many companies now, Linux is the first thing your average entry-level engineer learns. They're going to have to learn how to do this, and I don't think we can, as an industry, hide that. We're going to have to expose this, and we're going to have to teach some hard truths. We have this today, for example, when customers buy the wrong server and expect it to work, and they learn the hard truths about actually, compute is more complicated, and we can't hide this away around a sort of simple Santa Claus world behind this.
So are you talking about the complexity of understanding that the support engineers need to have, or the operators? Because I think there absolutely needs to be a complete abstraction of complexity from the people that are actually operating it.
I agree on the part of operators that so we do this, this happens today, for example. Many of the US truck companies are starting to deport certain operations to the cloud, such as the second and third graphics engines. I think most of the big truck operators in the US now deport that to the cloud as a kind of test, and the operators press a button and they're actually controlling a remote graphics engine. So we're already so for the operator, it doesn't look any different. But from a support engineering standpoint, as you say, there's actually a very complex chain behind a cloud instance running. Is that cloud instance provisioned correctly? Is the transport mechanism back to the truck in that production? The keeping of fill and key in sync, is it generated correctly in the cloud? How do you deliver fill and key in sync onto the ground, et cetera, et cetera? So hiding that around a kind of magic box as, well, I didn't really want to jump into that, but some of the proprietary protocols do, isn't going to help. But I wasn't trying to jump on that, but we can't kind of keep sugarcoating the reality of what's going on underneath anymore.
But we also have to provide the tooling to allow them to understand it, and the observability and the other things. We have to provide those interfaces into the tools that allow people to use that the IT people are already using to build and run their systems. If we don't work with those platforms, we fail them.
I think there's two questions. I think from a production perspective, I agree. The producer, the TD doesn't care really what you run it on and where it sits. Let's be perfectly honest. They just want to go to a push button, push it, and it miraculously appears. I'm with Kieran. For the IT infrastructure, I can stand up IT infrastructure way quicker than I can run around building complex broadcast infrastructure. So the benefit I see to client side is there's a bigger pool of resource available. So, and I think on the vendor side, we also had to recognize that. We had to bring in DevOps people to look at how we deploy this stuff, and not just to use the traditional rinse and repeat of how we did it in the past. But on the flip side of that, we stand up now major, large global sporting events with single people very, very quickly using tools like Ansible and Terraform. These are not broadcast industry specific tools. There's a lot of people who know how to use them and build CI/CD pipelines that can help a lot of clients. So I think I'm with Kieran. You've got to invest also in the people, the knowledge, and the expertise, and then you see the benefit of it. But even just take the security aspect of it, how quickly you can secure stuff in that domain, push updates, maintain it, isolate things, move things from one node to the next node to do maintenance. There are so many, plus I would really keep production separately and say there's hard caveats there, like an audio console that's connecting to back-end compute. The operator, as long as the experience doesn't change, they should just say, I don't really care. But the engineer that's got to stand up the infrastructure probably wants to do it in the most efficient way. And I think
Thomas's point this morning about making sure that we provide systems that can be deployed easily, rather than going this container image and nothing else, and it's 1804. We don't want that. So we have to find ways of delivering upgradable infrastructure.
But that's on us, right? So
yeah, exactly. It's on us to deliver it to the customer.
And so, the other side of it is, this approach allows us to even have a concept of digital twins. So I can even build infrastructure, see what it looks like, even build the production layer above, and not actually have to commit it to compute or to licenses and stuff. So there's so many benefits for it. I think you just have to embrace it. And this industry hasn't not been here. This was the same thing 15 years, 20 years ago when we moved from, proprietary edit suites to shared storage to MAM to cloud. We're just a little bit later because we have bigger streams and bigger content to deal with. So I do think that the knowledge is there. We just got to supplement it with some of the new ways of working.
If we follow modern SDLC practices, we deploy to a test system. What we deploy to test is what we're going to deploy to production. If it works on test, it should work on production. We can facilitate this process by being more intelligent about the way we use our tooling to deliver the goods to the customer.
But if you build a digital twin, you can also test it at scale.
Very good. Okay, moving on. We've mentioned a couple of times, a couple of you mentioned control. And one of my other regrets, I guess, of the story of 2110 and NMOS is the control plane lagged behind the data plane in terms of what we provided to the end user as a fully working integrated solution. And that's arguably why things like NDI have had so much success, because the control plane was fully integrated, even though it's got lots of other issues under the skin. So what does control and orchestration even mean when we're talking about deploying and controlling and setting up and tearing down and configuring software instances? And how are we going to address that challenge? So who wants to talk about what the...
Just for clarity, do you mean the control and orchestration of the platform or the real-time control from the operator's perspective at this point?
I was meaning more of the former, but you can cover anything you like. Anyone want to take the...
I think both are relevant.
Yeah, both are relevant.
Yeah, and that's a good point, is on the EBU, Dynamic Media Facility Architecture, Reference Architecture, it's a vertical layer, the control and monitoring layer. And I think it was hard to come to an agreement on 2110, and it's not yet really done about how we control things. Now we get it even worse because there's even more layers to control. And the fully orchestrated environment and dynamic environment needs to be controlled at all layers, be it on the spinning up of media functions into containers, being on the workflow integration of these different components, be it on the control, the live control of the devices, through generic control surface or web pages or things that are integrated into a single pane of glass to control all different functionalities. So it's a huge challenge in terms of harmonization. I like this morning this afternoon when Phil presented on his slides the idea that we could certainly agree on a couple of principles, like has to be an open API documented, that we could have criteria about these things. So already not necessarily trying to have one size fits all, but at least have a number of principles we can agree on to ease that evolution. And of course, we still work towards common open API in the AMWA. We're talking about Katina. We're talking about these things that brings a cluster of the industry together to try to address those things. But there will be homeworks at each layer in terms of what are the parameters and what needs to be communicated and controllable. Anyone else?
Steve, so you're saying that every vendor will be responsible for its deployment, and then there's going to be a layer above that orchestrate the sub-orchestration?
So again, an orchestrator is probably an important function, a very fundamental function in this system that could be done by one or a few products. But this will need to integrate all the other components, and since we want it to be multi-vendor, probably we'll have to live with different protocols, different ways. But in terms of functionality, I think this is where we can more easily agree, and we could write it down somewhere that this is the level of control we expect for each of these layers. What are the parameters to express the resource you need from the compute? Can we agree on these things? And then the rest is a question of protocol. There will be many, for sure.
I think, Felix, from some of the presentations you've done, my understanding, ideally, you'd like to be in a position where you go, I don't like that mixer, I like that mixer. I can swap a container around and bingo, it just works, right? That's the ideal world that you're looking for. But to get there, the orchestration of the mixer to bring it up has to be the same, and the control plane that controls the mixer has to be the same. Otherwise, you have to re-engineer to allow that swap. And I think those two things in themselves are massive challenges to get adoption. We don't have a common control protocol that fits all use cases that everyone has agreed on already, but that just doesn't exist. And the orchestration, to make the orchestration work, you need a lot of metrics to understand where to bring that mixer up, because the new one might need more resource or less, so it can be run up in a different place in a different way. So all of those things make this quite complex. I think somebody earlier on, we were preparing for this, referred to the God controller that would sit above everything and work out how to build a system. And if you're responsible for the God controller, I suspect you have quite a good insurance policy to keep your customers happy. So,
yeah, I mean, it's always the choice of words, orchestration, because when I always speak orchestration to a customer, the first thing they go to is the network. So you talk about an SDN. No, I'm not talking about an SDN. I'm talking about orchestration of the compute, orchestration of the apps, provisioning. And I think even if you look at 2110, what we're really talking with the discovery registration is really the discovery of the nodes and the flows. In this case, we actually need the underlying infrastructure to declare what it's capable of doing, what's its utilization. We need the apps to declare what they need. So when you create an app, what does it need? What are the prerequisites? And then I would say, if that's in a digestible data model, it doesn't really matter what the protocol is, because let the customer choose how they want to orchestrate. Some customers might have their own in-house tools. Some may choose to have a God service from a vendor that does it for them. But the data is still relevant to all the vendors. If I have an app, I need to declare what I need it to do for it to be successful. So I think that is probably going to be a bit of work, where I think every vendor who has a media function, the only reassurance they can give the customer is, this is what I'll need, and if you buy the underlying compute from vendor X, Y, Z, this is what they're going to need to make available in order to run that media function. And then it opens a whole discussion of like centralized, public, private registries of where do I get the microservices from? So, and that then is also part of the orchestration story of, okay, I want to put a switcher here, but actually I need to declare where it's actually stored.
So are you thinking from a data model for defining what the resource consumption would be, or an API to get a data model, or both in that, in that process?
I think if you make media functions, and the media function can go large, small, up and down, whatever, you know what you need as a vendor of an app. So you should declare in common sense language, if you're going to run this,
a data model, effectively,
this is what I need in order to do. Yeah. How you pass that to a God service or an in-house tool, I think is, as long as you don't damage the data model, how you pass it is entirely discretional.
I guess you also need that for the host platform you're running on as well, so you can find out what the capability it is to do the fitting.
That's right.
Yeah,
that's right.
So.
Another challenge I think we have in NMOS, which we have now, I think, successfully brought to market. Most of the resources that NMOS is handling are resources that are in boxes that are there, and all you're talking about doing is actually connecting them to each other virtually. We're now actually talking about instating and configuring things that are ephemeral, that don't even exist at the point you're actually building the structure. So there's quite the level of complexity in terms of what you're trying to do, as Felix said, is quite significant.
And might only hang around for an hour or so for that part of the show.
Exactly,
and then
that's the whole point of this, it is ephemeral. That's the significant benefit. Just moving on a little bit to the, there's been some talk, I know you talked earlier, Felix, about the SDK that is being looked at for the work that the EBU is doing. In the GCCG, what we've done in that data, for the data exchange, is purely defined an API. So who's taken the right approach here, and how do we converge that?
I think there are benefits to the SDK. We've seen that with things like NDI and SRT. It's a drop-in replacement to existing workflows. However, that does run the risk of the unfortunate thing of a lift and shift to cloud. So many of you probably tested equipment where one SFP port did one SDI flow at the beginning of 2110 because that vendor had clearly done a lift and shift, so you got really none of the benefits of 2110, multiple flows down a link, etc. But at the same time, it is dangerous a bit to go and, have some kind of centrally planned approach where one entity, some kind of, I don't know, for want of a better phrase, Soviet 5-year plan where there's one SDK that everyone must follow. And I think there's a danger, if we're not careful, of kind of the EBU doing a sort of 1980s thing where, we're the public broadcasters and you must follow this standard. And the world is not like that, a kind of Soviet-esque style plan, because the world is not like that. So APIs at least allow a level of abstraction. We can move between different platforms. We don't have to, if there's another approach other than the EBU, we can stick to that. An SDK, as we've seen with things like NDI, we're kind of stuck like in an Internet Explorer 6 kind of age. It got us to market quickly, but now we can't innovate because we're sort of hobbled by the history of the past.
Okay, would anyone like to respond to that?
Right. I struggle with what we've done for GCCG. I know we've defined an API because it's on GitHub and it's a header file. Yep. We know what that says. We've created some sample code that Appear took and built their modules from, using that as an example. Now, that feels a bit SDK-ish. It allowed them to accelerate their progress by taking that as a reference and building around it, and then helped us correct it, which is also the ideal software process of iterating quickly to refine the model as you go. So I think we probably need a process that is going to allow everybody to move at their pace and to share the information without being too prescriptive, as is being said, because if we do that, we will end up with everybody not doing it, or demanding a test set that completely tests it, and then we have to resource the test set, and it gets a nightmare. So there's lots of ways of making this difficult.
But to answer the SDK approach is, the target was to have a reference implementation that everybody can look at. And then it's software, right? If you want to derive from that, you have the full liberty to do that. But it's to show people that multi-vendor doing an SDK can work, and then there's a path forward. Right?
It does sound like we've done the same thing on where we are at the moment. We've just only got two vendors.
I would tend to agree that we're not that different.
We might have 3 by the end of next week, so that would be good. So.
I think it's also slightly different. I think there's licensed SDKs and there's community developed SDKs. I think they are slightly different, and that's why I go to my point in my slides, which is if you want to steer something in a positive way, you have to engage in the community to do that. If it's a licensed SDK, maybe there's commercial reasons why things don't necessarily get done, or maybe they're stagnant because there's a reason to let it stagnate. But I think the reality is you still need a reference design to be able to get going. I don't think that's the final reference design. I think it will evolve. It will evolve as we figure out some things that work don't work.
It's dead if it doesn't evolve.
I mean, just as an observation, we've talked about NDI and SRT, and I think two things. SRT is made open, and several people have done, dare I say it, better versions. And sorry, Rick, for even talking about it again. Than the original, whereas NDI haven't, and it's a very locked box that no one can touch. Wes has got a contribution to make. Wes.
So one of the things that rang a little alarm bell in my head when you were talking earlier, is talking about how to define the requirements for a module to operate successfully on a platform. And I go back to the work that was done just very recently on trying to evaluate switches for IPMX use. And going through all the data sheets and trying to read them, there was no consistency, no ability to say definitively, yes, this switch will be able to do it, or no, this switch won't be able to do it, etc. I'm curious as how we're going to take that and multiply it by a factor of 10 when we're talking about how do we know this server or that server is going to support the requirements. How do we express the requirements for a particular piece of software to run at speed and at scale, and know that when we load that on that server, it's actually going to accomplish what we needed to do.
Thank you. Anyone?
So I spent half my day job on this. It's getting worse and worse and worse because of green initiatives on every server, PCI Express issues, looking at Matt Jefferson there. So this is an immense challenge because the variety, the fragmentation of equipment that we expect to work on is varied. The complexity of the product is varied, so that's already not even a matrix, it's a pivot table. So it will have to be up to vendors to self-declare. So vendors will have to go and come up with their worst case scenario of, I will need X amount of resources. So internally we call this the t-shirt model. So we say, here's a small, medium, large, extra large, and now we have 100 gigabit, 200 gigabit, extra large. And we define that as a model, as a worst possible case. And yes, even customers complain, we get complaints from customers that we're not using enough CPU, I could be doing more, but we have to explain that actually our compute resource is set up for the worst possible case. And there's certainly an educational challenge there. And then that's that worst possible case in that scenario. You haven't thought about Intel versus AMD versus ARM versus Green Initiative Mode 1 on Dell versus Green Initiative 2 mode on Supermicro. It's a big challenge, but we have to have vendors self-declare.
And some of these resources are quite hard to measure as well because you can hit memory bandwidth constraints, cache constraints, networking constraints. So just because your CPU is not working doesn't mean the box isn't fully loaded. So it's not a simple metric. So I think the other thing I was going to say, and I'm sure AWS will correct me, but I feel there are hundreds of possible VMs that I could use from AWS with configurations on top. So it sort of gets worse every time you go near this for the permutations you can develop to put around it.
Okay, time is up. I want to do a round robin for the guys of where we go next, but Felix has a response on the SDK question before we get back.
Yeah, and I think we have more commonality than difference in where we want to land. We want to end up with an API and a data model in a frame buffer. It's just the way to get there. I think that was taking that is different. I don't know if you were there this morning when I explained, but fundamentally, it's the first step is to come up to that API with a trial and error process, which is implementing working code and making it work, and then fine-tune it with iteration. I would suspect that at the end we will land very closely in terms of what this API look like and what it's doing and what the data model will be, because I mean fundamentally it's not we're trying to do the same thing. So I think and then opening the door once this is crystallized to proprietary implementation, maybe implementation that comes with support, implementation that come with additional features. The goal is not to impose a single set of code for that. But that's more a process thing than I would say a technological architecture fundamentally.
Gentlemen, our time is up, but I'm going to give you 10 seconds if you want to pitch in and say, what should we do next? What are our next steps? What do we want to actually ask people about? What does the industry need to do to move forward on this? We've aired quite a lot of challenges. I think we've aired the opportunity that exists as well. But anyone want to jump in?
For me, we have to get everybody engaged in the initiatives that are going ahead. If you want to get involved in GCCG, yell. We would love to help you see how it works and help us iterate it to where it needs to be, which is probably not quite where it is at the minute. But that, I think, is going to help with the DMF facility as well, because all these things will iterate to get to the end game.
That's more than 10 seconds, Phil.
It always is.
I would say the same thing. I would say I had a lot of complaints about RISC not being adopted and lots of other things. This is exactly this inflection point. You've got to get involved if you want to have an impact in this. The customers won't wait, so get involved.
Kieran?
We need real world events, real world projects. The Tokyo Olympics was the turning point for 21 and 10 and NMOS. We need real world projects, otherwise it's a web streaming demo at NAB every year.
On the control side, I would like to hear what you guys require.
And the last word to Felix.
That's a lot of pressure. How to solve this? No, I think the fundamental thing is to talk about it and get together to understand those concepts and this overall challenge. And then there will be a number of homeworks to address this over the next few years. But I think we can move very fast in the short term to get the first demonstration and even production with this technology.
Well, thank you, panel. There's been a lot of discussion, one or two little bits of controversy on the way. It's great. I think this is the year we can make this happen. So would you join me in thanking